This video covers the production of a new pulley based on the shattered remains of the original as shown here. The diameter of work that the lathe will cope with is 7 inches or 178 millimeters, and the diameter of this pulley is only a fraction under that, so as far as diameter of work goes, it's on the edge of what the lathe will cope with. You can see with this straight edge held across the boss of the pulley that this edge is practically in line with the boss. But if I turn it over, looking at it this way, you can see there's a gap between this side of the pulley and the straight edge. So the actual groove isn't on the centre of the pulley. So using a weight to keep the boss flat to the surface plate. The only set of block gauges I've got are metric, so I'll have to work in millimeters. Well, that's a 3. I know from having played about that 3 just about fits. Under the edge here. That side of the pulley is 3mm set back from the boss. Looking at the height relative to the boss, 24 instead of 26. And that's just about spot on. So I can get the depth. Yeah, 10 millimeters. To make the form tool, I cut a sliver out of the pulley, which of course has the correct form. Then marked up a piece of tool steel with blue. And laid the piece out of the pulley on top and marked round it. And so I ended up with that. So that's 2.9. That looks a pretty good fit to me. So we'll set the tool back 2.9mm from the front of the work. We'll get the groove in the right place. I marked up a piece of 7-inch diameter, 178mm diameter aluminium bar using a surface table, some engineer's glue and a standing vernier to mark out the centre lines, with the intention of drilling a couple of holes in it so that it would be able to be bolted to the faceplate of the lathe. As you can see here, it took me a couple of attempts to get the centre line right, but got there in the end. The aluminium was then taken over to the drill to drill the holes by which to hold it on the surface plate. I didn't appreciate at this time that I should have drilled the counter bores at least another 3mm deeper, as I have to take 3mm off the face of the piece of aluminium, and I had to take it off the faceplate and bring it back to the drill to redo it at a later point, as will be seen. The chuck was then removed from the lathe, and the faceplate and aluminium bolted to it was then mounted instead. The next thing I noticed is when you move the saddle forward, the saddle which used to normally be able to move underneath the work now butts up against it. If you could get the saddle under, then the cross slide would be the next thing to come up against it. The aluminium was then faced and a thin skim taken off the diameter to give a starting point to work to. The vernier is only just big enough. 6.950 inches, which is 176.5 millimeters. As the shaft on which this pulley will turn is made of hardened steel, the plan is to bore out the centre and press in a piece of phosphor bronze, and then bore out the phosphor bronze to the diameter of the pin to give it a bearing surface to run on. At this point, the phosphor bronze I'd ordered to make the bush hadn't arrived, and as the tailstock of the lathe is 2 Morse taper, the best I could do at this point was to drill using the largest 2 Morse taper drill I had, and then move on to the groove in the pulley. I wasn't able to cut the groove that this pulley takes for wire rope in one cut, as there was a lot of chatter and a lot of stalling, and I had to do it piece by piece and then put the form tool in to get the correct shape. But in the end it got there very nicely. So I used the gauges and the vernier and a bit of blue to mark out what was needed. So we've got one edge of the pulley which is set back from the boss, then the edge of the groove, the other edge of the groove, and the back of the pulley, which is here. And at the moment I've just been cutting a slight groove with the parting tool into the very centre, having used the gauges again and the vernier just to calculate the exact position. I found a drill bit 28.25 diameter. I measured the centre as being 28.2, I think. Anyway, it fits. So I'm able to put this fragment on there, wind the tailstock up, just, you can see the pulley is just a fraction off the size that I've cut down to. It's practically there. 2.9, the gap between that bar and the cutting tool. That's better. started turning the heads of the bolts. Not being able to do any more facing at this point, I used the parting off tool to mark the rear of the pulley at the point where it would eventually be cut off from the rest of the billet. I plan to do this in the bandsaw. I then removed the aluminium from the faceplate to deepen the counterbore holes for the bolts to allow some more facing. As the phosphor bronze I'd ordered to make a bush to go in the centre of the pulley had now arrived, I used the opportunity of taking off the aluminium to remove the faceplate, mount the chuck and do some machining of the bush before having to put the faceplate back and then the aluminium back. That's got it. The phosphor bronze bar is 48.96 millimeters outside diameter, which is 1.785 inches. Looking at the existing pulley, 45.96 is about there. Cut it off in the saw, I think. Well, that's going to go in there eventually. So with the counterbores for the faceplate mounting bolts made deeper in the aluminium, it was remounted on the lathe, and with the phosphor bronze turned to a known diameter, the bore of the aluminium could be worked up to match that of the phosphor bronze. I haven't shown much of this here because it emitted a really high-pitched squealing noise. Once the diameter was obtained in the aluminium for a press fit, the phosphor bronze was pressed in so that it could then be bored to take the shaft. Though first the face of the phosphor bronze had to be cut down to match that of the aluminium. Having started using increasingly large drill bits on the phosphor bronze, I then turned to the boring bar to complete the job. with the phosphor bronze bush bored out to match that of the shaft on which it would turn. The pulley was moved, the aluminium pulley was removed from the lathe, and as it couldn't be held in the saw to cut it, held in a vise, and then the vise held in the jaws of the saw. Though, as you can appreciate, squeezing it from front to back will not allow the blade to cut all the way through, so it could be cut so far, then turned round, a piece of packing inserted to take up the gap so it wouldn't clamp on the blade, and the cutting completed. I think it must be through by now. Yeah, it's through. There we are. Phew. So 3 is the gap between the boss and the outer edge here. I got 3 there. Yeah, 3 there. So this height, well, I can just, it's going to run in there. I'll take this down to match this surface. Now, how am I going to hold it on the chuck? To hold it in the chuck, I had to make an arbor of the same diameter as the shaft that the pulley rotates on, with a thread on the end to clamp it tightly. Though as you'll see, I had a bit of trouble with the thread. .211. So 75, 85, 86 now to come off. I tried tapping an M12 thread in the arbor so that a bolt and a large washer could be used to hold the pulley on, but I didn't have much success. Either the tap rotated in the chuck, or the chuck rotated in the Morse taper, or the motor stalled. So in the end I gave up, took it to the vise and did it by hand, which is all a bit odd as it's not long ago since I was able to tap M16 with no problems. So the first thing to do, put the arbor in, clock it in so that that is central, and then put the pulley on and see how central that sits. This is the face I've got to do. Could be playing the bearings every time I pull on it. Moves forth out that way. Thinking about it, it's probably the bed moving relative to the piece of steel upon which the magnetic base of the indicator is mounted. It's not that thick. I have got a thicker piece, but I haven't managed to put it in yet. With the pulley remounted on the arbor, the face that was cut with the bandsaw can now be taken down and the width of the pulley turned to the exact size. The actual one is 8:15 and this one is 8:45, 30 thou over. $21.33. $21.02. I think that'll do. So that's it. I hope. I have to fit it now and see if it's okay. I think it will be. I was going to put a roll pin. I drilled, but the drill broke. Still, it's doing the job of a roll pin or a keyway. And the bush is a press fit anyway, so I'm not worried about that. A slight recess here. The bush I should have made the bush slightly longer. I didn't. I don't think that's going to matter. I guess this collar will be going on, well, I don't know which side it's going to be going on. There we are. From that to that.